This is Math 142. This is a problem out of 9.1. It's problem 76. And we are supposed to verify this equation, verify that the left side is equal to the right side. So, there's a couple different ways I go about doing this. I think what I will do with this one is, this is a proportion. This proportion equals this this fraction equals this fraction. So I'll do some cross multiplying. So, this times this, I'll just call it cosine theta plus 1. I'll just call it that because that's what it is. Secant times secant theta minus 1. And then tangent squared times cosine. I don't really need the parentheses, but I'll throw them in there. And on this left-hand side, notice it's just, think of it, it's like a binomial times a binomial. So you could FOIL it out, cosine theta times secant theta. And I'll just write that out, and I'll worry about what it is in a second. So cosine theta times secant theta minus cosine theta plus secant theta. Whoops, not squared, secant theta. And then what do I need to do? Oh yeah, 1 times negative 1 is minus 1. And I actually am proving this equal. I'm not sure that this is equal yet. I'll worry about this right side in a sec. Cosine times secant. Secant is 1 over cosine, so this is a 1. And then I have negative cosine theta plus secant theta minus 1. So 1 minus 1 is 1. So basically I have negative cosine theta plus secant theta. And, as you know, that's the same as secant minus cosine. So let's get to there. So now I'm looking at this side, and here I notice I have a cosine and a secant. Here I have a tangent and a cosine. So right now, if I turn this tangent into sine over cosine, cosines will cancel, but I'm not sure, I have a sine. I actually want to show that this is equal to that. So I think maybe my easiest thing to do is think about those Pythagorean identities. And one of them is the tangent squared plus 1. That's a plus sign. It's a very ugly plus sign. Is secant squared. So if I subtract 1 from both sides, tangent squared of whatever is the same as secant squared of that same thing minus 1. So I think I'm going to replace the tangent squared with that secant squared minus 1 right here. And again, the reason I chose this path is because I saw down here I had a cosine and a secant, and so I wanted to bring a secant into this problem. And so there's my cosine theta. So I'll keep going from here. Distribute this cosine into there, multiply it here and here. So I basically have secant squared times cosine minus 1 times cosine, which is cosine. And let me think about secant. I know that secant excuse me. Secant is 1 over cosine. So secant squared secant squared is 1 over cosine squared. So if I multiply this by cosine, it cancels out one of these in the denominator. 1 over cosine squared times cosine squared. Oh, no, just times cosine. It's just times cosine. Over 1. That cancels out one of these, leaving me 1 over cosine. So, and I know that 1 over cosine is secant. So notice what I end up with here then is this cosine cancels out with one of the cosines that's the bottom of this. And so this becomes secant theta minus cosine theta, and those are equal to each other. You could get that here different ways as well. You could take this side and split it up into cosine over secant minus cosine over 1 or something like that, and try and work to get it to here. I think this is a pretty efficient way.